Okay, moving on to Unit 9, we have the inferences of quantitative data, and we're looking at slopes. We're going to be looking at some least square regression lines here. Then we're going to start by looking at samples of distribution, confidence intervals of the slope. So when we're looking at these, we are looking specifically at the slope and seeing if there is a relationship or not. That's the main thing we're looking at with these regressions. And yeah, so let's get started. So first, quick overview for your least square regression. When you have a set of data, it is a set of data that you can put into an x and a y and see if there's a relationship for it. So here's some data for height and arm length, or arm span, if you want to use that term. And to find the least square regression, just a reminder, on your calculator, you push stat under edit. Stat edit L1, you type in whatever your x values are. L2, you type in your y values, and then you push stat calc, and then number 4 or 8. They both are linregs. One has ax plus b, and the other one is a plus bx. They're the exact same thing as long as you know where the slope is and the intercept, which the slope is attached to the x. Okay, so in this chapter, we use the letter b for slope when we're talking about a regression. So take a second, see if you can get the least square regression line with your calculator on this one. All right, and if done correctly, you should get approximately y equals 0.859x plus 24.616. All right, and that would be our linear regression. Okay, and the main focus here is that slope. So the number attached to the x, that's what we're looking at. And we want to see, we're basically finding the range in which the slope value is. Okay, so when we do a regression, we're basically taking a sample and we're creating an equation based on a sample that we can apply to a general population. So you have two different equations here with different variables. You have mu sub y is equal to alpha plus beta x. That would be the population's regression line, or what the actual regression line would be. But since we can't get population data because trying to gather every single piece of information is very hard to do, we take our samples, which is where our y hat equals a plus bx comes into play. And that's usually the regression that we are dealing with here. Okay, so we're usually dealing with these sample regressions, and that b value is what we're looking at and seeing the range, not the y-intercept, not the a value. Okay, so the sampling distribution of b, you're looking at its shape, mean, and standard deviation for it. Its shape should be approximately normal as long as all the criteria are met, or all the conditions are met. And we'll go over the conditions. There are actually 5 conditions that need to be met for this one instead of the normal 3. The mean, which is mu sub b is equal to beta. Again, it's centered, mostly just notation stuff here. And then the standard deviation is the standard deviation of the residuals, the r, which if you remember back when we were doing our regressions and everything, we found the residual, which was the distance from the regression line to the actual value. So the standard deviation of that over the standard deviation of the explanatory variable, okay, which is the standard deviation of the x values times the square root of n. Okay, so that's how our equation are, and there's many different ways of being able to find those, and we'll talk about some of those as we move forward. Okay, so when we're doing these regressions, we are looking basically to answer 2 different questions. First one is if there really is a linear relationship between x and y in a population, or could it just be happening by chance? So that's one thing we're going to be answering. That's kind of the key thing when we're looking at these regressions. Second one is in the population, how much will the predicted value of y change if we increase the x value by 1? Essentially, it's the margin of error of our estimate that we're looking at. So how big of a margin of error are we looking at? But the first question is kind of the key one here. We want to see, is there a linear relationship, or did this scatter plot just happen by chance? Okay, and we use statistics to be able to say, well, there's a 4% chance that this happened. And then you can make the judge on, well, either it's a 4% chance of happened or something's fishy going on. So we'll see. Okay, so your conditions here are, there's more than what we usually have. So normally we have our independent, normal, and random. When you're dealing with regressions, there are two other ones that you want to look at, linear and an equal standard deviation. So linear, essentially you look at the scatter plot or the correlation or the R value. And you want to see, does it seem like it's a linear relationship? If it's not linear, then we can't use a linear regression on it. Make sure it's independent, which is still your 10% condition, or if it's an experiment, your observations are independent of each other. I don't see that one as much. Normal. So the best way to check this one is to check the histogram of the residuals, and it should be fairly normal for the distribution. You shouldn't have major outliers. You shouldn't have anything crazy going on. If you look at the histogram of the residuals, they should all be fairly equal. An equal standard deviation. So the standard deviation, again, of the residuals doesn't change very much. And to do this, you would just want to plot the scatter, or the residual plot of this one, of the data, and then see if there's any patterns. So remember, if it creates a curve, or if they're all above or below, those are signs that it's probably not linear. So if it looks like it's linear, then it's probably going to agree with the other two. Okay, and it's just, you have to kind of show to say, hey, look at it, it works, which your calculator can pull those up really easy for you. It's just some fancy finger work on your calculator. Last one is the random, which is your SRS, or the random assignment. All right, so looking at specifically a confidence interval for the B value, which is our slope. Okay, so again, we're focusing on the slope here. So we're looking at the confidence interval for the B. And basically, you take the B value that was found using your regression, plus or minus whatever the T, the critical T value is, okay, based on the percentage, the area between negative T and positive T of a degree of freedom of n minus 2. Okay, so in this example, we're using n minus 2, not n minus 1, when you're dealing with a regression. Okay, but that's your critical T value. Again, based on the percentage that you have. But we use a T because there's a very good chance that we don't have the deviations, the actual deviation of the data. So that's why. And then your statement, we're C% confident that the true slope falls between these two numbers, yada, 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 context. Okay, so that's what we use. Okay. Yeah, and we'll go through that. If not this section, we'll go through a lot of those formulas next section. All right, so, yep. Okay, so let's look at a mini tab, which is the most common you would see with this, is you'd see a mini tab. You wouldn't have the actual data because it does take a long time, but you could be given a mini tab, which there's key pieces of information. This isn't new. We looked this back up way back in like Unit 1 or Unit 2. But here's the key pieces of information. There was only parts of it that we really looked at the beginning. The parts that are marked off in red, you never have to use. Okay, so the standard error coefficient of the constant, the T and P under the constant one, you never have to use. And then the last part's in the very end, which is the R squared adjusted value. You don't need to worry about those. But the other parts are all important. The numbers on their coefficient are your intercept and the slope. The slope is the one that is not the constant. The constant is the y-intercept. So in this case, the slope is 0.164. Okay. The rest of the numbers in that top part of the box along the slope, the SE coefficient is our SE sub B, which we'll see in a formula. The T value, which again, we usually use T here because we don't have the actual standard deviations. And then the P value, which is the P value that we've used previously. So like this one, the chances are 0.5% for it. The bottom part, the S, is the standard deviation, the residuals, and the purple one is the coefficient, or the R squared. So you take the square root of it, and you get your R, which tells you the correlation of it. Okay, so that's your mini tab that comes out. That's usually the most common one that's used, is this. So you got to know what each of those numbers are used for. Okay. All right, so let's move on to an example here. All right, so let's look at an example. Okay, so here's the mini tab that we have, and it tells you about IQ scores and musical aptitude, and there's a printout for it. Okay, so you can see the very top is the equation for it. This one actually gives it to you. So essentially the y hat is equal to negative 22.3 plus 0.493, whatever the IQ is, which is your x. So your slope here is that 0.4. And the question is to give a 99% confidence interval of the slope of this regression line, and does it suggest a linear relationship? Okay, so key things that we have to do, we are looking for the simplified version of this confidence interval is b plus or minus t star se sub b. So the mini tab actually gives you the standard error of b, and you don't have to actually do the calculation for it. Okay, so it tells you what the standard error, the standard deviation of the b value is. If it didn't give it to you and you have to find it by hand, that's where you use the previous formula, where it was the sigma over sigma x square root of n minus 1. But the mini tab, which is the most common thing you would see, they actually tell you what it is. So we take those numbers. It would be 0.4925 plus or minus 2.88, which is the t value in this case, because it's the 99%. And then we would multiply it by the SEB. And then we get our answer of 0.4925 plus or minus 0.35. So that means that the slope could be anywhere from 0.15 all the way up to 0.85. We're 99% confident that there is a slope between those two numbers. And because of that, and because that the slope is greater than 0, and it's not, the intercept doesn't include 0 itself, then we would say that there is some sort of linear relationship. So if 0 is not included in the interval, then you would say there is a linear relationship between it. But since the 0 doesn't fall between those two numbers, we would say that there is a relationship. If you had 0, you could say that there was not a relationship. Okay, so 0 is the key. Doesn't matter if it's positive or negative. If it's negative, you would just say that it is a negative linear relationship instead of a positive linear relationship. All right. Okay, so quick math on the calculator. So under your calculator, under all your distribution stuff, if you go down to G and the TIs, you'll see the ln-reg t intervals, and you'll also see ln-reg t test. Okay, so the interval obviously is the one that's going to tell you the interval. So it pops up, it's asking for the x list, y list, frequency, the C level, and the reg equation. Now, the ones that you type in, if you've typed in all your data into L1 and L2, X list is L1, so second one. Y list is L2, second 2. Frequency, keep it at 1. The C level, which you type in yourself, make sure you put it as a decimal. And then the regression equation, you do not have to put anything in that spot. You can keep it blank. It's essentially asking you where do you want to store it. So you could store it into like Y1 and then it's saved there. But you don't have, for the most part, don't put anything for that last one. And then push enter, and then a bunch of numbers comes up and it tells you the information you need. So take a second, read through this one and see if you can find the interval, 95% interval. All right, so looking at this one, we go through and we're looking for our key pieces of information here. Our degree of freedom is 8. Okay. Our B value when you do your regression is negative 0.072, and then the S value is 0.153. Plug those into your confidence interval equation, and from there you should be able to find the slope, which is from negative 0.08807 to negative 0.0554. Because 0 is not incorporated or not included between those two, we would say that there is a suggestion of a linear relationship between these two pieces of data. All right, and that's it. That's the end of section 1 of chapter 9, and we will be moving on to our last section, one last one.